Hello, dear class 7 students. Welcome back. And today we will discuss and we'll continue with the part 2 for lesson 7 science, physical, and chemical change. So you can all turn to page 58 to 67, 58 to 67. So in our last class, we have discussed difference between physical and chemical change, right? And we have seen activities for physical change. And I have explained about chemical change. And one example that I gave you was regarding rusting of iron. And regarding this rusting of iron, we will see in detail, okay? But now, you know that rusting of iron is a chemical change because here a new substance is formed and we do not get back the original substance, right? So we will see the first activity for a chemical change. So are you all ready? Okay, so let's get started. So to understand the chemical change more better, we will see an activity. So here, do you see this metal? Are you all familiar with this metal, dear students? Do you know this is a magnesium ribbon? Okay? So this metal here that you see here is a magnesium ribbon. Okay, magnesium ribbon. Now, through this activity, we are going to learn more about chemical change. Okay? So what you have to do is we are going to burn this magnesium ribbon. Okay? So this is a magnesium ribbon and we are going to burn this magnesium ribbon. But you have to be very careful. Before burning, we have to clean this magnesium ribbon with a sandpaper. Okay? A sandpaper. And we should be very careful while burning this magnesium ribbon. We should not just hold the magnesium ribbon with our hand, but we should use a tongue. Okay? A tongue to hold this magnesium ribbon. So now, after we start burning, let's see the observation. What do we see? This magnesium ribbon burns with a white flame, right? It burns with a white flame. So from here, what do we notice? We see that there is an evolution of gas, right? And in our last class, I told you about chemical change. In a chemical change, a chemical reaction takes place, where we will see an evolution of gas and absorption of heat. Now here, we are seeing that magnesium is burning in the presence of air. We have this magnesium and then we are burning this, but here we have air. We can feel it, right? When you do like this, we can feel it. So it is burning in the presence of air. So magnesium is reacting with oxygen and we are burning this one. So now what do we get? Do we get any new substance or do we get a magnesium metal back? So let's see. So once it is burned up, we see that we get a powder, a white powder, an ash. So what do we call this? This is not just a white powder, but this is, we call magnesium oxide. Okay? We call this as magnesium oxide. So this one we got as a result from magnesium reacting with oxygen. When we burn the magnesium ribbon, as a result, the new substance, the new product that we are getting is a magnesium oxide. So this is magnesium oxide. Now, like I have said, while experimenting this one, you should be very careful. You should hold the magnesium ribbon with a tongue, okay? And then you should make sure that you are cleaning the magnesium ribbon with the sandpaper. So students, this is an example of chemical change, right? Because we got a new substance, we saw evolution of gas, right? We saw that it absorbed heat, it released heat, right? So how do we write this equation? We write in this form, okay? So student, it is very simple, okay? We will learn this together. So now, this is magnesium. Magnesium, that means the ribbon, the metal ribbon that we use, that I have shown you. This is magnesium. Okay? And this is oxygen. That means the air. Okay? The air that we can feel it. You do like this, you can feel it. Now, when we burn this one, when we heat this one, what do we get? We get that white powdery thing. What is that? That is magnesium oxide. Okay? So magnesium and oxygen reacting together, we get magnesium oxide. This is the new substance that we are getting. So this one we will write like this. Magnesium. Okay? For chemical equation, we'll write like this. Magnesium, the symbol is Mg. Mg. Oxygen, you'll write O2. Okay? And the product, magnesium oxide. Magnesium, how do we write? Mg, right? And oxide, we write O. So this is how you represent a chemical equation. And this is not a new thing, but this is from, we are writing from the experiment, from the activity that we did, burning a magnesium ribbon in the presence of air. Okay? So now you are clear that this is a chemical change. Burning of magnesium ribbon is a chemical change, right? We're getting a new substance, and then here evolution of gas is taking place, right? And here is releasing heat as well. Okay, so students, now, the next thing, this magnesium oxide, that means magnesium oxide means this one. Okay, this one, now further, we are going to use it. We are going to use it for another activity, okay? Another activity. So this magnesium oxide, what we'll do, we'll mix with water, okay? Let's dissolve it in water. Let's see. So here, now you can just mix the magnesium oxide, that powder and water in a beaker, or you can use a glass, okay? You can use a glass. So it will look like this. Okay, if you take that ash, the magnesium oxide, and you take water and you dissolve it, then it will look like this. So what do we call that? When we mix this one, we call magnesium hydroxide. Now this is not magnesium oxide, okay? Because we have already mixed this, dissolved this with water, so we call this as magnesium oxide, hydroxide, okay? We call this magnesium hydroxide. Now, in our last class, we have learned about acid base, right? And we use a very common natural indicator, right? That is a litmus paper. And commonly we get two litmus paper, that is blue litmus and red litmus. And students, blue litmus, if it changed to red, it is acidic, and red litmus, if it's changed to blue, it is base. So let's check this. Okay, this product that we got, either it is an acid or base. So when we put a blue litmus here, it does not change its color. But when we put a red litmus here in this calcium hydroxide, it changed to blue color. So red litmus is converting to blue litmus. So that means it is a base, right? So students, the powder which we got, okay, after burning the magnesium ribbon, that was magnesium oxide, right? Now when we mix that magnesium oxide with water, we get this, and this we call magnesium hydroxide. And if we put a red litmus here, it changes to blue litmus. That means this magnesium hydroxide is basic. It's base, okay? So now we are done with our first activity for chemical change. Let's see our next topic, okay? But before that, students, you can just write this equation down, okay? Or you can mark with pencil in your textbook. This is from the activity that we have performed just now, okay? So this is magnesium oxide, that the powder one, okay, the white powder which we use, we write as MgO. Magnesium oxide, we write MgO. And what did we mix in that powder? We mix water, right? So we have H2O, right? H2O. And together, what does it become? It becomes magnesium hydroxide, okay? Magnesium hydroxide. Here we have a chemical formula for magnesium hydroxide, okay? So you can have a look at this simple equation and you can note this one down, or either you can mark this equation in your textbook, okay? So dear students, now we will discuss and we'll start our second activity for chemical change. So you can all refer to your textbook activity 6.7. Now, dear students, the crystal, the blue color crystal that you see here is a copper sulfate salt. Okay, it is a copper sulfate salt. So you can see here, it is blue in color, it is crystal, okay? And it is also known as blue vitriol, okay? So it is blue in color. Now we are going to make a solution. We are going to make a solution for this. When we say solution, that means we are going to mix it with water, okay? So we are going to make a solution. And we will put a diluted sulfuric acid in this solution. Now students, what are we going to do? So students, here we are going to put an iron nail. Iron nail, we call it as kujal, okay? Now we have a copper sulfate solution, right? In a copper sulfate solution, we are going to put an iron nail, okay? So copper sulfate, it is blue in color, right? So when you put an iron nail, and after half an hour, we will see what changes does it occur, okay? So after half an hour, we see that the copper sulfate solution, which was blue in color, has changed to green in color, okay? It has changed its color. So during the chemical change definition, I have explained that in a chemical change, we also see there is a change in color, right? So here, students, we can see that the copper sulfate solution, which was blue in color, here we have put iron nail. And after half an hour, what do we observe? We see that it has changed to blue in color. And along with this, we also see the change in the iron nail. Iron nail, usually it is silver type in color, right? But now we see that there is a brown color, a brown deposit in this iron nail. Now the iron nail has also changed its color, right? We see a brown deposit here. So dear students, here chemical reaction has taken place. We got a new substance, okay? Now chemical reaction does not mean only getting one new substance. We get more than one substance here. So students, we have seen that now the copper sulfate solution, which is blue color, has changed its color. So now this product that we get the green color here, it is iron sulfate or ferrous sulfate, okay? And here, the brown color deposit that we see here in the iron nail, it is copper, okay? Copper. So here we can see that change in color take place. So students, you can write this simple equation like this, word equation. Now, we had copper sulfate, which is blue in color, right? Copper sulfate, which is blue in color. Now, what did we add there? We add iron, right? We add iron. So after adding iron, after half an hour, we observe and we saw the change in color, and we also saw a brown color deposit in iron nail, right? So that solution we get to see after a half an hour is an iron sulfate solution. That means iron sulfate solution is green in color. And in the iron nail, we saw a brown color deposit, right? So that is copper, okay? Copper. So this is the second activity. And from second activity, we see that there a chemical reaction take place in a copper sulfate solution. And we also see that there is a change in color. And we got, as a product, we got more than one substance, right? Okay, so now students, let's see this one. So here we can see a baking soda and a vinegar, okay? Baking soda and a vinegar. Now this is common, right? So in our last class, in our last chapter, acid, base, and salt, also we discussed about baking soda and a vinegar, right? So baking soda is a base and vinegar is an acid, right? Because it contains acid, it is sour. So now with these two, we will perform a simple experiment, okay? So let's see. So we have baking soda and vinegar. Now what are we going to do? We're going to mix them together, okay? So it's a mixture of baking soda and vinegar. Now when you mix a baking soda and a vinegar, you will see that there are lots of bubbles, okay? Like this. And you will hear a sound. You will hear a hissing sound. Okay? You can try this at home. It's very simple. So students, like I have said, in chemical change, we will also get to hear sound, right? So here, when we add a baking soda and a vinegar, we hear a sound. And we also see a lot of gas evolving from these bubbles. Okay? We see a gas evolving from this bubble. And with this gas, the gases that we get from this experiment, we are going to use for further experiment activity. Okay? So this is how the mixture of baking soda and vinegar look like. Okay? So you can try this at home. Now, students, what did I say? I told you that when we mix baking soda and vinegar, we see a gas evaporation, we see the liberation of a gas, right? So this gas we are going to collect and pass in a lime water, okay? In a lime water. When I say lime water, it means locally we say tuna and it's water, okay? So it's a solution of lime and water. So we are going to pass the carbon dioxide gas in this solution, that is lime water. Then what do we see, students? What do we observe? Now, the lime water, which looks like this, it converts into a milky insoluble particle. Okay, milky insoluble particle. So you can have a look. This was the lime, this is the lime water, but after we pass the carbon dioxide gas which we got from the mixture of baking soda and vinegar, we got the lime water has changed into a milky insoluble particle. So we have a reaction here. Okay, students, we have a chemical reaction here. So this calcium hydroxide, this is calcium hydroxide, and when we pass a carbon dioxide gas, CO2, what do we observe? We get an insoluble particle which is milky, that we call as calcium carbonate and water. Okay? So students, from here also we have seen the change in color, right? We have seen evolution of gas. We also, when we mix a baking soda and vinegar, we got to hear a sound, a hissing sound. So these are all examples of chemical change. So dear students, this is all for today. We'll continue in our next class. Thank you.